Alright, now that you have done sine rule, cosine rule, now we need to have a look at the area of a triangle. And those of you who haven't done measurement last year, you may not be actually familiar with some of the finding the area of different shapes. So what I'm going to do in this video is I'm going to take you through various shapes and calculating its area. So let's start off with the first one, which is a triangle. And I'm going to look at three different shapes for the triangle. The first one is a right angle triangle, and I think all of you should be familiar as to how to work out the area of a right angle triangle. So I'm going to label this. So let's say this is going to be the height of the triangle, and this is the base. And so the area is given by half times the base times the height. And if the triangle is something like this, actually I need to redraw this. Let's try this again. Okay, so I can make this to be the height over here. And remember, the height is always perpendicular to the base, so this is the base, and that is the height. And if the triangle is somewhat like this, I'm running out of space over here. I think I'm just going to squeeze this in here somewhere. Okay, let's see if I can. So if the triangle is something like this, let's try again. Oh, let's try this way. Okay, so I think this is too tilted. Let's try that. Okay, here we go. So I'll consider that to be the base. I think that's all. That's why I'm having these issues. Okay, base, and the height is from here all the way down. So, and if I just extend the base in this direction, so this is the height. Alright, so there are three different types of triangles, and all of these, they use the same rule to work out its area, which is area is equal to half base times height. So if you want to write this in full, area is equal to half times the base times the height. And in short, we write this as that. So if you want me to do an example, I can very quickly do an example. Maybe I'll just do 2, and I'll just draw the triangle over here. Let's have a look at this. Let's draw this one here. And the other one I'm going to do is this one. Right. Let's say the base over here is 25 centimeters, and the height is going to be, let's say, 10 centimeters. So the area is going to be half base times height, and that gives me half times 25 times 10, and that is going to be 125 centimeters squared. For this one, let's say the height for this comes out to be 15 centimeters, and the base over here is going to be, we're having some issues today. Okay, let's try again. Okay, that's much better. And base, let's say, is 6 centimeters. Therefore, the area of this is going to be half base times height, which is equal to half times 6 times 15, and this gives me 45 centimeters squared. Okay, so that's using the triangles. Now, I'm going to go to the next one, which is a parallelogram, area of a parallelogram. And to draw that, so if I'm going to do this, oh, it didn't snap to the shape. Let's try again. There we go. So you will notice the opposite sides over here, they are parallel to each other. Okay, and the height is given as this, that is the height, and this over here is the base. Therefore, area of this parallelogram is given as base times the height, which is equal to that times that. And looking at example, so if I draw something like this, let's say the base here is 25 centimeters and the height is 6 centimeters. So the area is equal to base times the height, which is going to be 25 times 6, and that is equal to 150 centimeters squared. What happened here? Let's try this again. Oh. Okay. Okay. Now I haven't done the area of rectangles, so I think I should change this area parallelogram and rectangle over here. So for rectangles, I'm just going to do an example because this is very similar to the above. Let's say if I have something like this, it doesn't like it. So that's a rectangle there for me, and the base over here is going to be 20 centimeters, and this, let's say, is 15 centimeters. So the area over here again is given as base times area is equal to base times the height, and in this case base is 20 centimeters times 15, that is going to be 300 centimeters squared. Now sometimes the base is also called the length and the height as the width, so I think what you need to be aware of is that if you have a rectangle like this is more of a square now. Sometimes this is also called the length L, and then this is the width W, and the area is also given as length times the width, so that is going to be right. Next one I want to look at is area of trapezium. Okay, so if I have a shape something like this with the opposite side, these two sides over here, they are parallel to each other. This is called a trapezium. Okay, and you might also get a trapezium which is a right angle trapezium, which might look something like this. Okay, so in here this is going to be right angles, so that is going to be side labeled as A, this is B, and that side there is the height. In here, this side is called, so let's say this side over here is called the height, that is side B, that is A, and the formula for finding the area of trapezium is given as A is equal to A plus B divided by 2 times the height. So in short, we'll write this A is equal to half into A plus B times the height. So this formula over here is used for finding the area of a trapezium. And now what I'm going to do is I'm just going to do one quick example. Alright, so let's say, so in this example I'm going to work out the area of this particular shape, which is the trapezium, and A is equal to 4 centimeters, B is equal to 8 centimeters, and that's the height over here is 6 centimeters. So plugging all these values back into the formula, area is equal to half into A plus B times the height. A is 4 plus B is 8 and height is 6. So 4 plus 8 is 12. 12 times half is 6. So that is going to be 36 times 6 is 36 centimeters squared. So that is the rule you use to work out the area of a trapezium. The next I want to look at is area of a circle R. So area is given as pi times R squared. And circumference of a circle so if that's the circle there that we're looking at, then C, the circumference is given as 2 pi times the radius. So that you need to know, because the reason why we need to know these, the circumference formula, is because you'll be needing this to work out the length of the arc, and you also need to know the area of the circle, so that the formula for the area of the circle, because you will be using this to find the area of a sector as well. Okay, so let's do a quick example. Find the area and circumference of a circle with radius 5 centimeters. So the radius is 5 centimeters. The area is going to be pi times radius squared. So in this case, pi times 5 squared, and that is going to be 25 pi centimeters squared. I'm going to leave my answer as 25 pi, but if you want to simplify that, you can use the value of pi from the calculator and work that out. Looking at the circumference, C is equal to 2 pi r, so that means 2 times pi times the radius, which is 5, so that gives me 10 pi centimeters. So circumference is basically the length around the circle, whereas the area is the space inside the circumference. Okay, that's it from